In this problem, we're going to talk about inclined planes. So consider that we have a block that is lying on an inclined plane that makes an angle alpha with the horizontal. Then we can decompose the force, the gravitational force, that acts on the object. Remember that the gravitational force just points upwards and has downwards and has a magnitude of mg. And we can decompose it into components that are perpendicular and parallel to the plane. Okay, I'm gonna call them y and x. So f in the y direction is equal to minus mg cosine of alpha, and f in the x direction is mg sine of alpha. Okay, and in our problem, what we have is a situation very similar to this one, where alpha is equal to 22 degrees, and the mass of the block is equal to 7 kilograms. Okay, so in question A, our goal is to find what is the acceleration of the block as it slides downwards. Well, the only force that acts on the block in the x direction is the gravitational force, and the acceleration in the x direction times the mass, so let me write it as the mass times the acceleration, is equal to the mass of the object times g times sine of 22 degrees, since this is the only force in the x direction. The m's cancel out, and the acceleration in the x direction is just g, that's 9.8 meters per second squared, times the sine of 22 degrees. So the acceleration in the x direction is equal to 3.671. Let me round it down to 3.67 meters per second squared. Okay, then in question B, we have to suppose that the length of the inclined plane is 12 meters, and that the block starts at the top of the inclined plane and then slides downwards. And at the top of the inclined plane, the block is at rest. So what I'm going to do is use Torricelli's formula in order to find what is the value of the velocity, of the speed, I'm sorry, of the block at the bottom of the inclined plane. So remember that Torricelli's formula tells us that v squared is equal to v0 squared plus 2 times the acceleration times delta x. In our case, v0 is 0, so v is just the square root of 2a delta x. Now the acceleration, as we found, in the x direction is equal to 3.67 meters per second squared, while delta x is 12 meters. Notice that both the acceleration and delta x are in the same direction. Okay, that's important. So v is equal to 9.39 meters per second. This is the final speed of the block.